Okay, I really needed a picture to say what I was trying to say. Here's this region. And here's an exaggerated height of 0.1. That height's more like 0.6, according to the scale. But so I could draw the thing reasonably. Just imagine that it looks like this, but it's only about 1/5 as high. Just a small sliver, right? So the area I think is certainly less than 0.2. Because again, here's a base area of 1/2. That would be all this, right? Which would correspond to this area, okay? And then this is less than half of what you'd have here, or maybe half, okay? So we could calculate the base area, but I'm guessing it's less than 0.2. If I'm wrong, then my estimate is what's good. Okay? Now, not sure about your geometry background with solid figures, but if you want the volume of something that has a constant height, you multiply the base area by that height. Okay? It's a basic principle that we don't have time to develop. Okay, so the volume would be this, 0.02. Okay? Now I'm going to make a little bit of a jump. I'm going to say, well, if the average height is 0.1, then if you multiply that by the base area, you get the volume. So that the average value of z on this, the average height of this, is just going to be this integral divided by the area of this base. So I can say then that the average z value is the volume divided by the base. If you understand that the volume is the height times the area of the base, then this makes sense. Whether it makes sense or not, that's the definition of the average value. Well, that is what? That's the integral from 0 to 1 and from y to the square root of y of x squared, y squared, dx dy, divided by the area, which is just that y looks like a 4. Okay, right? Okay, well, if I accept your result, which is a little questionable because you got that negative, but it seems reasonable. It's right in the range of what I estimated. Incidentally, if it turns out it's wrong, it's much more likely that you're less than 1/30th than you're more than 1/10. Just on record, okay? I'm pretty confident that the error is less than 1/10. Well, we divide this by this integral, right? Well, if we do that integral really quickly, integral from 0 to 1, integral from y to the square root of y dx dy is the integral from 0 to 1 of square root of y minus y dy, and that's going to be really easy, okay? Square root of y is, well, you got 2/3 y to the 3/2 minus y squared over 2 evaluated from 1 to 0, which is 2/3 minus 1/2, which is 1/6. Okay? Now that compares with our idea that the area of this thing is maybe, well, it turns out that it's 1/3 of the area of this half of the unit square, okay? Because 1/6, 1/3 of 1/2. Okay, so this is over 1/6. That equals 0.3. So now I'm beginning what I was